Hi everyone, Assalamualaikum. In this video, we are going to continue with Chapter 2, Hyperbolic and Inverse Hyperbolic Functions. Alright, first, we recall back what inside hyperbolic functions. Okay, we have 5 topics under hyperbolic function. We done discuss the definition and identities of hyperbolic functions. In this video, we are going to discuss how to prove the hyperbolic function using identity and definitions. Okay? Right now, we look at how to prove the hyperbolic function using identities. Hyperbolic identities means cos squared A minus sin squared A equals to 1, or 1 minus tan squared A equals to sec squared A, or cot squared A minus 1 equals to cosec squared A. Alright. Now we look at example 1. Show that cosec squared x plus 1 equals to cot squared x. Okay. To show that left hand side equals to right hand side, let's say we start with left hand side. Okay. Then we equate the last row equals to right hand side, which is cot squared x. Okay. From cosec squared x here, this is reciprocal function. So we can write cosec squared x equals to 1 over sin squared x. And then plus 1 here, since we have fraction here, so we can write 1 as a fraction. And since we have denominator with sin squared x here, so we can write 1 equals to sin squared x over sin squared x. Okay? So that when we simplify, we get back 1. Right? And then from here, we have same denominator. So we can combine the denominators. Okay? So we can write 1 plus sin squared x over sin squared x. Okay? And then from here, to get the last row here, to get the function on the right hand side here, let's say we start. Yeah? So from the last row, we move up. Okay? Alright. When we solve cot squared x, okay, or when we use identities under cot squared x, okay, this is reciprocal function, which is 1 over tan squared x. But since we have in terms of sin here, so we can write cos squared x over sin squared x. Okay? Because cos squared x over sin squared x equals to cot squared x. Now, we need to check whether 1 plus sin squared x, is it equivalent to cos squared x? Okay, because now we have same denominator, but maybe we're not sure whether 1 plus sin squared x equals to cos squared x. Okay, so from this identity, cos squared A minus sin squared A equals to 1. Okay, from here, because we have sin here, so we can refer identities in terms of sin. Okay, so from here, we can refer this formula. Okay, alright, since we have variable x here, so we can start with cos squared x minus sin squared x, which is equals to 1. Okay, and then from here, to write in terms of 1 plus sin squared x, we can move minus sin squared x to right hand side. Okay, so left hand side, we get cos squared x, and then equals to, after we move minus sin squared x to right hand side, so we have 1 plus sin squared x. Okay, then now we have 1 plus sin squared x, which is equivalent to cos squared x. Okay, means that this row equivalent to this row. Okay, and then cos squared x over sin squared x equals to cot squared x. which is equivalent to right-hand side. Alright? Now, we done prove that left-hand side equals to right-hand side. So, it is shown. Right? Alright, now we continue with example 2 under proving the hyperbolic function using identities. Right? Hyperbolic identities means this formula. Okay? Now we back to example 2. Verify the hyperbolic identity sin x over cos x minus cosec x equals to cos x plus 1. Okay? To verify left-hand side equals to right-hand side, first, let's say we start with left-hand side function, which is sin x over cos x minus cosec x. And then we equate the last row equals to what we want to verify, which is cos x plus 1. Alright? From here, we still have sin x, and then cos x is a reciprocal function of tan, which is 1 over tan x. But since we want to verify in terms of cos x, so we write cos x equals to cos x over sin x. Okay, we write in terms of cos because we want to verify in terms of cos x. Alright? And then cosec x here is a reciprocal function of sin. So we can write cosec x equals to 1 over sin x. Alright? From the fraction in denominator here, we have same denominator which is sin x. Okay? So we can combine. Okay? So we can write sin x over in bracket cos x minus 1, and then we combine the denominator sin x here. And then from here, we can simplify and we can write sin squared x over cos x minus 1. Okay, we can move sin x here up to numerator here. That's why we get sin squared x. How we get this? Okay. Alright, from sin x over cos x minus 1 over sin x, we can write equals to sin x. Over here means divide. Okay. Divide by fraction cos x minus 1 over sin x. Okay. And then equals to sin x. Divide here, we can change to multiplication operation. But we need to exchange numerator and denominator. So, multiply by sin x over cos x minus 1. Right? Sin x here means sin x over 1. Okay? So, we multiply sin x by sin x from numerator here. So, we get sin squared x. And then over 1 here, we multiply by cos x minus 1. That's why we get sin squared x over cos x minus 1. Right? Okay, so now we have sin squared x over cos x minus 1. Okay? So now we look at what we want to verify. Okay? We want in terms of cos. Okay? So it means that we need to write sin squared x in terms of cos x. Okay? So how to write sin squared x in terms of cos x? Okay, from here we can use identity. Okay? From hyperbolic identity cos squared x minus sin squared x equals to 1, we need to write sin squared x as a subject. So to write sin squared x as a subject, we can move minus sin squared x to right hand side. And at the same time, we move 1 from right-hand side to left-hand side. So we get cos squared x minus 1 equals to positive sin squared x. Right? Now we have sin squared x equals to cos squared x minus 1. Okay, so we can write here sin squared x equals to cos squared x minus 1 over cos x minus 1. Okay, so from this fraction, we need to simplify until we get cos x plus 1. No more fraction. Alright? So, how to simplify from this fraction to cos x plus 1? Right? Okay, from cos squared x minus 1, okay, we can refer from algebraic formula, which is a squared minus b squared. It is equals to a plus b times a minus b. Okay, we can write cos squared x minus 1 equals to, in bracket, cos x squared minus 1 in bracket and then squared. When we compare with algebraic formula, our a equals to cos x and b equals to 1, right? So from this formula, we can write cos squared x minus 1 equals to a plus b, means cos x plus 1 times a minus b, means cos x minus 1. Okay, so from here, we can write cos squared x minus 1 equals to cos x plus 1 times cos x minus 1. And we still have denominator cos x minus 1. Okay, from here, we can simplify cos x minus 1 from numerator and cos x minus 1 from denominator. After we simplify, we get cos x plus 1. Right? When we compare to the function on the right-hand side, it is equal. Means that we done verify sin x over cos x minus cosec x equals to cos x plus 1. Alright? Coming up next, proving the hyperbolic functions using definition. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.